Welcome. We're live on the 22nd of January, 8 o'clock till about 9. Live from Studio Westhaven in Amsterdam, the Netherlands. The title of this webinar is Machine Learning at ING, Automatic Classification of Income and Expenses. First of all, two gents at the table right here, Bas Gerding and Tassos Kagimanis. Welcome, great you're here.
Very well said, actually. Well, it's the first time I hear my name so brilliantly pronounced. Thank you.
Yeah, that's when we're live, we do that. Before we go into the introduction, can I ask a very simple question to the both of you? What can a participant expect from tonight's webinar?
What can they expect? Like if they can expect interesting story from ING and some source code actually. So we try to tell a great story with some depth in it. So that hopefully they can learn a bit and get some inspiration from us.
Great. And Tassos, what is your promise for the participant?
Well, we have already created a very nice solution that's going in the market soon. And we just would like to share with the world. Well, inspiration is one, sharing the knowledge and the lessons learned is the second. We have all experienced that from other people and would like to share that with the world. So.
Great. When we look at the first slide, I see a big elephant and some greyhounds racing. What is this race all about, Bas?
Yeah, that's a good question, by the way. Yeah, we are the big elephant, actually. We are the big ING, the large enterprise that have already existed for tens of years, actually. But the financial industry is changing, and we are trying to compete with the new kids on the block, basically, which are the fast little dogs. We call them the fintech startups. And we, of course, we're winning the race, as you can see. So, yeah.
But this is the current situation, huh? A lot of people, when it's about machine learning or whatever in tech, great companies, big companies, and small, fast ventures around you.
Yeah, we just mentioned actually the key word. So the elephant symbolizes, apart from a big company, even though the elephant is very fast, it shows that it's not so agile, it cannot turn so fast. And now things that are changing, agility is actually in the center of all companies that's actually to accomplish that. So now we actually try, from our part at least, make ING a more agile organization in terms of, really giving the solutions of the 21st century challenges.
Cool. To introduce both of you, we here have one slide. Bas, this is you.
Yeah, that's me. I've been working at ING already since 5 years, more than 5 years. And before that, I did a lot of other jobs. Always working with data and with artificial intelligence, machine learning, because that's also my background. And you can find me on Twitter, LinkedIn, etc., if you want to.
What is ING Labs exactly? Because that's your workspace.
Yeah, ING wants to innovate, so ING is actually investing a lot of money currently in new services and new products. And ING Labs is the incubator, the startup hub, basically, that resides within Amsterdam. We operate from Amsterdam, and we actually try to bring new ideas to life, to production. That's it's a bit more difficult to realize in other parts of the bank. So a lot of the startups that you see there are starting from greenfield. They think about an idea, and there they get the time, the room, the budget to experiment and to fail fast or succeed. And yeah, that's basically what we do.
And you also work together with those greyhounds then, I think, eh?
Yeah, that's true, that's true. Of course, ING is not always competing the fintechs. We're also trying to work together with them, because we have something that they sometimes don't have, which is, for example, customers, for example.
Small detail.
Just a detail.
Some details.
And we can actually benefit from each other. Yeah. So there's really it's really an enthusiastic bunch of people that work together there in an agile way, indeed, to deliver new service to our customer.
Yeah. And Tassos, you are on the next slide.
Yeah.
You're from Greece, huh?
Yeah, I'm from Greece.
And how did you get here?
Well, I came for a master in econometrics. I did my first degree in financial engineering, and then I went to do econometrics. I came to Erasmus University of Rotterdam, like 2007 already. And since then, after my master, I've changed quite a few jobs all around analytics, and since 2013 or 12, I think, I got the title of data scientist, which was like a very early stage of calling somebody data scientist. It was actually the sexiest job of the 21st century back then, from Times of New York, like as the magazine said. And it's a very interesting field.
What makes you think, especially when it comes to machine learning?
Well, since I was young, I was really good in mathematics and really into it, and always wanted to solve problems. So essentially, modelize the environment that I see around me. So essentially, I'm doing my childish dream come true. So I'm really dedicated and committed to what I'm doing. I really enjoy it, take pleasure. But apart from that, it's really brilliant. Like it.
Oh, that's cool. And then you work at a good place.
Yeah. I think I'm in the right place on the right time. Yeah.
But when I visited your LinkedIn profile, I figured out you also are a master brewer at the Goat Brewery in Rotterdam.
Yeah, that's true. Unlike other data scientists, I would like to bring in front also the human behind the data scientist, which is sometimes forgotten. So yeah, indeed, I'm a brewer. We're already selling beer like in around 10 bars in Rotterdam. It's a clear hobby, not really money is involved in that. No. But I really take a lot of enjoyment. I mean, drinking it with friends and brewing it, of course. New tastes, so it's really nice.
How does this beer taste, Bas?
Don't know.
I only tasted it once because he only gives us beer when he's happy. You know, he says he's sharing it with friends and not with colleagues. So, but it's really nice. It's really nice. So,
nice. We have some administrative announcements as well. If you follow this webinar via live stream, you can ask us questions. And we like the interaction because it's live, and you're more than happy to answer those questions. Your colleague Ana Palomares Gomez is moderating the chat, so feel free to contact her, and she will forward the most interesting questions and comments to us here at the table. I will pick them up from my screen. In case you're attending the live stream on YouTube, just asking the questions is not possible. Then go to live stream, and probably we can answer all your questions, since we have quite some participants live at this moment. I see 164 at this stage, only on the live stream app. And it's good to know that this live webinar will be also on demand available afterwards as a replay, and it will appear on Tweakers soon as well. Let's go to the machine learning part.
Okay, well, we start with some slides, folks. And first, I want to present the first slide, which is an introduction of ING, but probably everybody who's in the webinar already knows the bank. But maybe a fun fact to share about ING is actually that we have over 35 million customers. So we're not operating only in the Netherlands, but as a worldwide bank, we're one of the biggest enterprises in this area. And that actually makes it very interesting because we have a lot of data to work with. All these customers are, of course, producing millions of events and interesting data points per day. Next slide is actually the corporate slide. It's probably the least interesting and the most boring slide of today, but I want to highlight it anyway because it contains our strategy on a page. It's the group strategy of ING. We want to empower people to stay a step ahead in life and in business. But that's not so interesting. What is interesting is actually that our work, of Tassel and me, is right on top of the priorities list.
Number 2, huh?
Yeah, if you look at number 2 of
Some people call it first,
priorities, then it's our hobby and our work, basically. Because ING says we want to develop analytics skills to understand our customers better, and that's actually what we do here. So that was, I think, a nice thing to highlight.
What does that mean for you in your daily practice? I mean, do you really experience it as that?
Yeah, we really see machine learning and analytics, or the broader term artificial intelligence, AI, as really a means to make things better for our customers and to automate a lot of things and to automate things more cost efficient, of course. You have to imagine that in a bank there's a lot of traditional processes that are now being done by hand or by old-fashioned traditional systems, and a lot of them can be automated and can be improved by machine learning. And that's also what we recognize, of course, but what we're happy to say is that also the management recognizes, the board recognizes.
Yeah, and on the slide before, I mean, you're also Europe's biggest online bank.
Yeah,
I mean,
true.
When you're in machine learning, when you're in the data science business, this is a nice working environment, I can imagine. You can really do impactful work on impactful solutions.
Sure, yeah.
Essentially, we see ourselves as a data company. So this is really in the core of what we're doing, especially in the innovation center, not really the more traditional, let's say, bank. But we see ourselves as a data company, and I think every company nowadays should consider themselves as a data company, or else the disruption of the digital technology is going to tear them apart. So
how do you see this for yourself as a data scientist? Because it's nice when the big boss says so. But how do you see it in your future field of expertise?
In which sense, you mean?
Yeah, when data is becoming more and more important, and they say, we're a data company, Everybody says so. But
well, now we are up to an extent in the center of attention, if you can call it like that. So there are some key skills. The demand is way bigger than the supply, as we all know, the data science field of all levels, junior to, I don't know, manager or product owner. And in the near future, it's only going to grow. So we are indeed in a very hot field. But we should not forget that this hot field was, for example, SAP a few years ago. Things are going to change. Nobody knows exactly how. And it's also a different topic to discuss. But great question. It's something that especially the new data scientists will look into to see how they can develop themselves, for example, which skills they should develop and what skills are going to be needed, let's say, in the future. Because if you develop something now, you need to wait also for some time until it's actually practiced.
And we're hiring, by the way, so.
Okay. Recruitment.
Sorry.
Advertisement.
No,
yeah.
sorry.
Black advertisement for recruitment. Yeah.
But I want to give a little bit of introduction into machine learning first, because I don't know how many people have already worked with machine learning or these kind of fields yet. But probably a lot of people have been programming computers. And I want to share a bit of the difference and the added value of machine learning versus traditional programming. So when you learn to program, when you learn to write software, basically, what you actually do is something like this. You write yourself a little program and you provide it to a machine. It runs on your machine, your software runs on your machine, and then you give it some input data. And what comes out is some output data. So in a very simple case, for example, you would program like a mathematical function. You give it some data like x is 3 and outcomes static predetermined value like y is 11. So in this can of course be much more complex than this, because it can be an entire set of business rules. It can be a really complex application that defines your business outcome for you. And this is actually how the majority of the software that we develop is still running. But luckily I have a data scientist here next to me. There's also a new field of research and new opportunities currently, which is machine learning.
Yeah, indeed. So the previous example said the simple thing. We know that if we give a specific input, we have a specific output. So it's like the calculus that people do in the elementary school. But yeah, unfortunately, life is not like that, right? We can see that in most of the cases there is always a specific error. So that's actually why statistics and machine learning exist. Because you actually have to take this error and minimize it. So essentially everything we have, instead of like having the x equal to square x plus 2, we actually create a function. Maybe we can put here the blue. So something like that on the left bottom corner, where you can see that, for example, if you input 3, then the output is 14. If you input 1, the x I mean, the y is going to be 2. It's very interesting to see that on the third and fifth line, we have actually the possibility that you may enter the same value, but you have a different output. This, in the previous logic of programming, should be the case, because it should actually follow some specific steps. With machine learning, this is not the case. We actually use some sample data, we calculate the error, we try to minimize the error, and essentially create an algorithm that essentially minimizes all these errors and give the result that we actually want. So we're not perfect, but up to an extent we make the minimum error towards all the repetition we have.
Of course, what's the interesting thing is that the program that comes out from your machine learning algorithm, which has been learned by example, can be used again in an application that we are programming in a traditional way. Yeah. For example, the application to get a loan, which is the example that we highlight a bit in the future, uses a machine learning model, but a lot of the code around that machine learning model is just typical software that we have been written in the old-fashioned way again. But that leads again to new output. For example, people that will get a loan, they will have their transactions analyzed, and that output can then be fed back into the machine learning model as new sample data to improve the model again. So we have a nice feedback loop going on there.
That's really brilliant, actually. It's something that's changing the way we used to work in the past. In the past, you need to know to have like a data set, which really complete, don't know how many lines, and that's it. You train it, done, or maybe you can take some more data in the future. But now with these feedback loops, essentially what's happening is that you actually continuously feed your machine or your algorithm, your machine learning algorithm, with more data, making it actually stronger, more robust, and of course more accurate. And this can happen actually in a flash of a second, which is actually what makes many people completely crazy nowadays, of how we can actually reach this level of accuracy, and the fact that the machine can actually correspond to our wants and needs.
Yeah. So give a bit of a summary, I think a lot of cases we can use machine learning. Machine learning can be useful in certain cases where you want to learn from examples, where you want to learn from sample data, and we just let the machine figure out basically what the best way is to reach a certain conclusion. And these kind of cases are happening more and more. Because the data volume that we have all around us, not only at the bank but also in social media and everywhere on the internet, is increasing enormously. And big data is one of the big advantages when you use machine learning algorithms. Basically, the more data of good quality, of course, high quality data is a must-have basically. The more of that, the better, because your machines get trained in a better way. Machine learning is also traditionally a very good approach when it comes to pattern detection and things like image recognition, complex algorithms that are not so simple to capture in if-then-else rules or in traditional software programs. Recommender systems, so customers who have bought this also recommend this. Or if you watch Netflix, then you see recommendations based on your personal customer profile. Those things are not easy to capture in traditional rules. That's where machine learning is coming to the rescue, basically. But also, there's some cases where machine learning is not so useful.
Indeed, indeed. Well, if you have a very, very small data set, maybe a simple analysis would be enough in order to get the results you want without complicated things. Low quality of data, of course, doesn't really leave so much space for statistical analysis of any kind, machine learning included. And of course, like when the pattern is really, really obvious, like, I don't know, something extremely simple, then you don't need really an algorithm in order to distinguish what you want. Generally, when the pattern is obvious and very easy to be seen, then you don't really need to complex things, essentially, with algorithms, machine learning or artificial intelligence, but just to go through that. But this was pretty much the old way of thinking. If you think of your problems and what you're doing every day, you're going to realize that you can produce data, you can use big data for that, you can create something more complex, and you can always have an algorithm that is better from that. But this, of course, depends on the application and how the person who is doing it is actually seeing the future and how visionary he is or she is.
Okay. We have some questions.
Yeah,
we asked the participants for questions, so here they are. I can tell you your colleague Anna is quite busy at this moment. Jörg asks, are you using Python to build these models and, for example, SGD for minimizing error? Are you using Python?
Yes, we're using Python. Yeah.
Come back to that later as well in this webinar.
We have some code examples in Python, but in general, data scientists want to work with the best tools, basically. And Python is one of the best programming languages for building these kind of models. There's also other languages basically that provide the frameworks and the tools that you need for this. What I like about Python, to get a bit forward ahead to that actually, is that it's actually also a very decent programming language. So it's not only that it's a modeling environment where you can run all your statistical analysis and your machine learning models, there's also a mature programming language where you can do testing and run code in production.
Oh. And a demo we'll do it in the second part of this webinar. Is it also Python based?
Yeah, it's Python, yeah.
Oh, great. Other question from Leonard, and I'll ask this one for you, Tassos, since you're a mathematician as well.
I'm not a mathematician, but...
Come on. You studied everything, you told me.
Not everything by any means, no.
Leonard asks, how to start with mathematics of machine learning as a software engineer? Since for me it's the most daunting part of the field.
That's a good question. Well, I think that the first thing you should do is to start with one of the courses that exist online. So Coursera and Udemy, I think they do an amazing job. There are also great books which you can start with. But as a recommendation, I would just say that when you start these courses, have an open window with Python, and whatever you learn in the course, just make it happen. In general, things are relatively straightforward. Of course, I don't know if you don't have any kind of background in mathematics, but nowadays things can be explained quite nicely with visuals, videos and pictures. In the past, in the books, it wasn't like that, right? Nowadays, I think you can have it, you can have an understanding of, for example, what is a random forest or a decision tree just by the graphic representation, and you don't really need to go in all the details. By the way, Python is hiding a lot of these details, which, if you're not really interested of exactly how the algorithm works, you can have like an understanding of top level and being able to use it, which if you're a software engineer, you just want to develop your skills, you don't have to burning yourself learning something that other people spent years to do.
I think it's also a big advantage of living in these ages, this age group. When I studied AI 20 years ago, I started that, by the way, and I finished it in 2004, but a long time ago, we still had to program our own C programming modules to run a neural network or a classification or regression model, those kind of things. That's all a bit in the past. So it's interesting to see that, to know the background of that, with concepts like gradient descent that find the local optimum, etc. of their algorithms. But if you don't care so much about that, you can also just use the framework that are readily available for you at this moment.
Yeah. Let's proceed.
Okay, yeah, we want to, what I said, machine learning is becoming increasingly important at ING, and we thought, okay, what is the best way to actually to present it to the audience? It might be that we can highlight a lot of cases and give examples, but actually it would be better probably to do a bit of a deep dive and actually show some examples of the models that we are using here, just as one of the examples that we use at ING. So the example that we picked is actually the one that we work on a day-to-day basis, which is the categorization of transactions. So you have to imagine that people spend money all the time, and they earn money. And in that transaction information, the payment transaction, that contains a lot of information. And if we can classify correctly to what category of spending or earnings these transactions belong, then we can do very useful things with that. For example, give customers a prediction on how they can spend their money, or help them on their customer journey. And also we can form an overview of what we call the creditworthiness, or the ability for customers to pay a loan. So that's the example that we are taking at this moment. And Tas is going to explain a little bit, because it's a complex situation. We just get transactions data of customers in, and we want actually to define if a customer can, for example, afford a house, get a mortgage, or buy a brand new car, which will take a lot of money. So it's a really complex problem.
Yeah,
Tassos.
That's why I have my crystal ball, and I was asking. No, it's not the case. Well, in our case, I'd like to come with a quote from Leonardo da Vinci: "Simplicity is the greatest sophistication." What I mean with that, what we're doing is quite complicated. Behind every app we're actually using, there is something really complex happening, but the simplicity that's actually presented to the customer is actually giving a great sophistication, which is what we actually like as customers when we do the app. This is what we try to do also with data science. There are a lot of complex things, but eventually the output is going to be usually one single number, hiding all the complexity behind it. So what Bas was saying before is that just want to show how important are the loans nowadays. So if you want to find like the perfect car, or you want to start a new business, or you want to make a new degree, for example, new master or PhD, or even if you want to buy a house, to come back to our example, you need to borrow some money if you don't have it. And most of the people actually do that. As you can see here, Bas, we have like a lot of loans.
Yeah, this is not the loans of ING, but this is the amount of people that actually in the Netherlands have one or more loans. So that's almost half of the Dutch population already. So getting a loan is actually a very important decision for a lot of people. And what we want, and what of course all the customers want, is to be that as seamless, easy process. And unfortunately, it's not the case at the moment. As you can see in this slide, and specifically going into, for example, the mortgage case, it takes a lot of time, and it takes a lot of paperwork as well, a lot of stress. The process of actually getting to the decision, to the final decision of yes, you can buy this house or this expensive car or whatever you want to buy, is actually it's not one of the easiest processes. But indeed, going back to the machine learning models that we want to build, if we can use them to automate some of the basically human decisions, or extend those human decisions in some way, then we can actually improve this process tremendously.
Yeah, indeed. Well, in 2019, the process should be easier. So many times I have already applied for a mortgage in the past, like I find all this process extremely difficult and painful, both in terms of how much time it takes, but also the effort that needs to be taken. So actually, if you want to find like your house, your car, your company, we try to change the whole process, to take the pain out of the equation and help both the organization as well as the customers take what they want the easier and fastest way is possible. So instead of taking like all the documents needed, we just make a minimum collection of documents, while some other documents we can collect them on ourselves with APIs. Yep. This we can see actually from the digitalization. Can you please go back to...
Oh, sorry.
Yeah. Well, after we have actually collected these documents with APIs, we don't have to put somebody actually check them one by one and check them manually. Actually, we can create an algorithm that can actually do that for us and just give us with a green or red color instead, in case something does not go well. So essentially, you can have an approval that can take minutes or a day instead of many days and a lot of effort from the customer. This means that the whole process is going to be seamless. You're going to have an answer very fast, and the most important, especially for the case of the house where people may wait for 2 or 3 months in order to take a mortgage, with consequence to lose their house, you may be able to actually purchase your dream house or any other kind of thing that you actually want without really putting too much effort like it was in the previous time.
Yeah. I have a question in between, gentlemen, because we ask questions, we get questions. Jackie Xu, is there a policy on privacy and ethics that researchers and engineers follow when it comes to the machine learning applications they build?
Absolutely.
Because we're talking about my spendings as a consumer.
There's always one of the first questions that I get, of course, and the answer is absolutely yes. First of all, before we do anything with the data of customers, we ask their consent, which is a way to inform customers and to get their approvals to do something with their data. You'll see that happening more and more, because if it's not needed, and we don't want to use this data in this way, actually, only if it's in the customer's interest. And of course, we follow all the laws and regulations, and we actually believe that the data that we have at ING is much safer at a company such as ING than certain other organizations, because of the fact that we are regulated. We are a regulated company that gets audited, etc., etc. So that means you can trust us.
Yeah. On top of that, just to mention something that maybe our fellow follower Jackie is going to find it interesting. The data that we're currently training our model are actually anonymized and completely. Yep. So we have actually changed all the fields, from the value of the transaction to up to an extent the description of the transaction, and of course even the date. Still, though, we can actually capture the patterns that exist in this transaction in order to be able to distinguish what is a salary and what is a debt. So essentially, without being able to connect that back to the customer, to the original customer, nobody can, because we have deleted how we did it. And it's done with a random manner. We can still get only the interesting patterns that will help us and the customer move forward with their work, without any kind of problem of, connecting back to the initial ID, which will be against the GDPR laws.
Yep, okay. Back to the slides.
Yeah, the data science to the rescue was the title of your next slide.
Data science to the rescue. So this is, of course, the slide. We're going into a bit of the how-to and into how we're going to do this. Because indeed, let's take a sample use case again. We want to determine the affordability of the customer or the creditworthiness of the customer. How we actually do that is we take a set of transaction data from the customer that we are allowed to see. And actually, what we actually do is we try to classify each transaction in a certain category. And the categories that we are mostly interested in currently are salaries and income and debts, because that takes up a huge part of the decision to give somebody a loan, yes or no. So the first step that we actually do is that we try to predict for every transaction that we see in this data set for one customer, we try to predict whether this single transaction is actually a salary or a debt. Or it might be something else, of course. If you spend your €5 lunch, then we're not interested in it at the moment. We can classify it a little bit, but in this use case, we're not interested in that in the moment. That's actually only the first step of classification. After that, we also have to aggregate and combine the data to actually come to the monthly amounts of salary and expenses on debts that we will be using in our future models for these customers. So it's a two-step approach, basically.
Yeah,
dat was.
So a little bit more on the data science side of things. So okay, we have some data about how actually we move from some raw data to a successful classification and prediction. So this is really a typical flow that everybody can find on the internet, and this is pretty much what most of the data science and statisticians are using one way or another, with small alterations. So initially we have to import the data, so we have them somewhere saved, and we put them in the system. In our case, it's going to be the AWS SageMaker. After we import, we're going to do some cleaning and some combinations of variables in order to bring it up to a level where we can actually go forward to the feature extraction. The feature extraction is maybe the most important part of the whole process. This is the part where we actually make our variables. We make essentially the columns that are going to forecast and make the predictions. No model with bad features are actually going to be successful, and the feature is what characterizes a good model from a bad model. After we have that, as said, we select the model that we want to have, or we use different kind of models with different parameters and fine-tuning in order to produce some results. I said before, we import the data, but we don't use all the data in order to train our models. Usually we break it down into pieces, the train set and the test set, as I said. We use the first part, the train set, in order to train our model, and the test set, as I said, to validate our results. So did the model train correctly, and what was the performance of that? After we have made a lot of iterations through the whole process, and we can speak hours about that, but it's not the case now, we actually have a model, and based on that we can put any input that will follow the features that we have created before and have a prediction. In our case, this is going to be like a set of transactions coming for a customer, and we're going to predict which of these transactions individually is actually a salary and which of them are actually a debt or is nothing.
Yeah. So again, back to this two-step approach, basically, where you said, okay, the machine learning is used to come up with an algorithm, and the algorithm is used to score the rest of the transactions as we are getting them in, basically, to make this classification on the transaction data. Okay, yeah, we have some technology for this. Basically, at ING, we're basically free to use technology as we like, certainly when it comes to frameworks and Python or any kind of programming language that we use.
A question from Tibor and Oudenbos.
Yeah.
Does ING use one of the standard ML frameworks like CNTK, Theano, TensorFlow, or does the ING has built their own solution?
Yeah, well, thank you for the question, but the answer is just...
yeah, that's why I asked it.
Yeah, excellent. Yeah. Right, that's great.
Well, for this example, we typically, we don't, we use some natural language processing. Yeah. So NLTK was one of the specific frameworks that yes, we are using that to basically do natural language processing, like removing the stop words, like making the nouns, TDIDF, those kind of things. But there's also other frameworks for that, of course, that you can use. Yeah. And currently, yeah, we use the technology that's on this stack. So sklearn is one of the frameworks that can do the machine learning for you. NumPy and Pandas are basically the core mathematical frameworks where you can do the in-memory data transitions that you're using. And Anaconda is you can call it our environment for Python to run, basically. Also, we run Anaconda in production. And they have some tools like joblib to save the models, and our IDE, our development environment, is currently PyCharm that we use to develop our software with.
Yeah, just to lay the last part, because I heard before, we haven't run any neural networks yet, or deep learning, so Theano and this approach is not valid for our case, but it's something that we consider actually for the future. It was in the question before.
Another question from Gajin. He says, sounds great what you're doing. Are you doing this at scale, or is it experimental at this stage? I think you have several projects working on, of course.
This project is actually live. So we're running this in France currently, but it's not being used too much. We're still kind of learning from the initial tests and the initial customers that we have here. But I have some examples of account classification, transaction classification for other use cases, which any customer of ING can actually use currently. So I'll come back to that later a bit.
Great.
Yeah. Good.
Yep. Go ahead.
Continue.
Yeah. By the way, I have to mention. You think you have an intensive job tonight? Anna is really working hard. You are asking a lot of questions, so please keep doing that. But please know that she can't answer all of them. But
okay,
keep
no, please, guys. Anna can manage, like, send more questions.
She has a tough job already. Okay,
go on.
Back to I think the machine learning a little bit further in depth, and I think you can take the explanation of the models.
Yeah, sure. So within the solution that we have actually created, a lot of things were actually tested and tried. So running actually machine learning algorithm is not like I'm going to do 1, 2, 3, and that's it, I have a result. Usually you have to go all around it. You have to test things, you have to change, alter, and play with it. In our case, what I want to show you here, it's only some of the algorithms or the general methodology that we're actually using for providing these results that were actually successful in our case. So starting from the top right, the top left. I'm confused now with the camera. The top left, we have the machine learning, the NLTK and count vectorizers. There are many count vectorizers. In our case, TF-IDF seem to be the most appropriate one. Then we do a lot of clustering, and we use DB scanning. DB scan, as we're going to see afterwards. The reason for that is that we want to cluster information together in order to find some similarities between them. This is very useful for identifying the transactions that are actually similar to each other. Time series and recurrence, we'll put them together. If you consider it, like all transactions are actually time series. So recurrence is actually very important, and we have created quite a big number of different features or variables, name it as you want, that can actually help us identify this recurrence in the algorithm. PCA. Well, PCA is used in some parts in order to make a to decrease the dimensionality of our set, because if you have too many variables, then the model actually is not robust anymore, and we just want to keep only the information that actually matters. Last but not least, of course, the classification algorithm. In our case, we're going to see afterwards, we used random forest, but many more actually models were used. We'll see that in a bit.
Yeah, actually, so all these models might seem a bit complex. We will try to show them in a little demo in the next session, the next minute, basically. But first, explain a little bit that there's actually a pipeline of these models that we picked to run this, to actually get to this prediction. Huh?
Indeed. So up to an extent, I mentioned them before. So DBScan, for example, DBScan can cluster similar transactions together. Well, the similarity comes from some parameters which I'm not allowed to discuss here, but some people that have some knowledge in data science probably are going to understand which one of them. The natural language processing essentially comes and gives us a great solution. It was really key to the success, because it creates features from essentially words and description. So it has really helped us to help the model perform well. Last but not least, from all the models that I have actually tried, we're talking about simple classification models. The random forest was the one, generally the ensemble techniques, was the one that produced the best results, and the one that actually chose to go forward with this application. Yeah.
And another big advantage of the random forest also that is it's in a way explainable. Eh? So we also get a lot of questions about, hey, can you a machine learning model can seem like a black box. You give the machine some input. There's a output there. Yeah, okay. The machine has learned that this is the right output for this input, but how does it make that decision actually? And where's the human touch in this? Well, by picking a random forest instead of, for example, a neural network, we can actually see the decision trees, so to actually see the decision that the machine has made to reach this decision. So we actually have a form of transparency, and we can explain what the model has actually made for decision for us.
Yeah. Well, as said, like we have a few more models, and for the enthusiasts that would like to know a little bit more about which are the good models that can play around, they're not the only ones, but I think these 4 ones are the most major ones in terms of classification, maybe with XGBoost as well. So we tried also support vector machines. They were a bit slow. Quite heavy, and they didn't produce so good results. Naive Bayes, on the other hand, didn't produce very good results, but was extremely fast. And of course, logistic regression is the one that all the times I'm running, I'm using as a benchmark. And I think that it's a good benchmark to see how your model is doing compared to kind of the most simplest model you can create. So yeah, on top of that, as you probably know, there are many parameters which you can tweak and twist. And for this purpose, in order to find the best model, we applied this grid search, which is actually nothing more than taking all the combinations of parameters that you actually put in the model and finding the one that has the best characteristics. The best characteristics in our case is what is the trade-off between recall and precision, and of course the accuracy of the model.
Oh,
sorry if I went a bit more in depth. Please send your questions if you have.
No, we are here for the in-depth session. That's why you're here.
Exactly, yeah. But I can imagine there will be like a huge variation in the audience, and I would like to capture both. But
yeah.
Is there any questions, Camille? Or?
Yeah, we have questions. Yeah, we have. No worries. One from Thijs. Do you also publish research papers?
No, not currently.
No, but are you thinking about it?
Well, ING is certainly promoting this and actually working together with universities in some ways. We have scholarships, we have internships, we have master students that come to graduate at ING. Yeah. So that's actually a part of what we do as a bank. Oh. Currently we are too busy basically with the current work to do any research now.
A good question from Eddie then. How big is your AI team at the ING Innovation Lab? Well, the two of you, or?
No, we're more. Now we work in a team that consists of 3 data scientists. So besides Tassos and Anna, there's also Nicola. That is just focusing on this classification model. But at ING Labs, there's around, I think, 10 data scientists. If you look at the entire ING, we've set up a global analytics unit. So a global analytics team of only data science and data engineers. And I don't know the exact number, but it's several hundred of engineers, data scientists combined. Yeah.
That's quite a spot then.
It is, yeah.
Question from and then we go to the demo from Wouter. But regarding to your testing of models, how often do you recalibrate your model, and what kind of results does this usually give?
The recalibration. So we didn't have too much time for recalibration. In our case, we had other kind of challenges, even though I accept that. In our case, we had in the beginning very bad labeling of the transactions into salary and debt. So we actually have to put a huge effort in making this happen. Now the data set we actually have, it's quite smaller than the original one, but still we try all the combinations in order to create the best model. For this purpose, and answer to his question, we're using k-folds, so we're using as much more information from the training set in order to produce the best model. In the future, just to give a little bit of the vision of what we're doing, we would like actually to expand in every 3 or 6 months in a specific periodicity. I would like to expand our data set as well as use the data set from the people that are using the app in order to retrain the model and expand it to the test data set. I hope that this captured your question.
Yeah. And a question from Patrick, and then we go to the demo. Yeah. Because people ask a lot of questions about your team as well. Yeah. What does your typical team for these kind of projects look like in terms of roles? Software engineer, data analysts, and also what ratio?
Well, we have a standard way of working, and actually we try to keep the teams quite small. We call them squads, by the way. Yeah. And a squad is typically a multidisciplinary team that includes business people, like customer journey experts or marketeers or product developers, together with engineers, IT people, software engineers, front-end engineers, UX designers, and data scientists. We are in a team of 10 currently, and that's actually already one of the big teams there. Mm-hmm. So a team typically is 7 or 8 people, and that is a good size to keep things in sync and to keep on communicating well with each other between business and IT people. Yeah.
And is it nice for you as a pure scientist to work together with those business people?
Yeah, personally I love it.
Yeah, why?
Well, it has to do with my background, the fact that I understand them. So in many cases what is happening is that the data scientists and the business people come from completely different environments. Yeah. And from both environments, the one is speaking bad about the other. So there's a prejudice, essentially one against the other, which creates a specific class. The business people want to focus on some area, the IT people in some, so there's always a conflict. From my side, I always like to work together with the business people because essentially we have to solve business for the problem. It's not like a research, and this is pretty much where you have to put a line of, yeah, I'm doing research and I'm creating all this, I don't know, these papers that would be really great from giving really an answer for the people that are using an application. So being hands in hand is extremely important, and I would really put highly on my high value on people that can actually being able to cooperate with each other, bring together the business with the IT or the data science.
We also learned from the past where data scientists were put in a corner somewhere, in a dark corner, and they were doing their magic. You know, they were
basement, put them some food inside, like feed them, and
we've been and done that. But then what comes out of that is like an interesting model, like a sample case or a formula or a report. Well, that's good to have, eh? And we put it in a drawer somewhere and it's never being used again. We actually, of course, want to use the models in production. That's why we have to keep on working on that, keep on fine-tuning them, keep on seeing how they behave in a production environment. Yeah. So it's really crucial to bind these people together. Yep.
Let's start up the demo, Bas.
Yeah.
What are we going to look at?
We're going to look at sample data. We're not going to show the real source code and real data of ING here because we're not really allowed to broadcast it in that way.
No open source tonight.
No real open source, although we also publish open source projects, by the way, currently, but this is not one of them. But it's pretty close to what we actually do in production, and it just gives an example of how these models are being developed. So the training steps and the
environment.
And the environment actually that lead to a model that we can run in production, we can pick up and put them and plug them into one of our use case software applications. So I'm going to switch to...
Start it up, I would say. And in the meantime, for you, if you have any questions regarding this demo, just type it in and I'll try to
yeah, so what you actually see here is a Jupyter notebook environment. Let's see.
Which is running in SageMaker.
Yeah. So I'll switch to my Chrome.
There it is.
And yeah, maybe you can see it, but because I have a really powerful laptop here, which is my MacBook, which is great. I'm really happy with how it performs. But still, for a lot of cases that we have to, for example, to train millions of records of data, is not nearly powerful enough. So we connect to an environment where you can process big amounts of data. And in this case, it's a cloud environment on AWS. It's called SageMaker. That runs a Jupyter notebook. It runs in my browser, as you can see. And it's actually a set of code samples that we can execute and that we can run with behind this the big power of a big data environment, a big data cluster. And we can scale it up and down if we need to. So it's an on-demand, pay-per-use environment. And if I would say, hey, I need to do, for example, a very heavy algorithm, I want to train a neural network, or want to do a grid search to tweak and tune the parameters, and I need 10 machines or 100 machines for that, it's easy to scale up and down in that way. So that's what you see here. And I'm not going to don't be too eager.
It's mine. No.
I'm not going to pass you the notebook, so be careful.
All right.
And in the meantime, Jackie is asking, will the demo and the sample data be available to the viewers and others?
No, unfortunately.
Well, we can maybe share some of that, but let's discuss it later, because I'm happy to put some of this code forward in some way that they can actually see it later. Yeah.
Otherwise, Jackie can also connect with you on LinkedIn, and then you...
But yeah, of course, this is always an option.
Yeah. We're happy to share, but of course you also have to understand that we're not going to put the whole core mechanisms and the core machine learning openness outside of the new one.
And Jorik is also applying for a job as junior data scientist with an MSc degree. Is that okay?
That's always a good idea. Yeah.
Well, actually, we have two people from the HR currently with us now in the studio. So
yeah, but do they have to apply via the traineeship part, or can they also connect with you on LinkedIn?
Well, both. I don't know.
Yeah, they can connect.
Yeah, that's cool. Well, Jorik, you have some advance. Go ahead, Maar. Okay.
Indeed. So, I would like to start. Well, you see here the environment of the SageMaker. SageMaker is actually something that we found out from the third data scientist, Nicola. The proposed is actually really great. It gives you a pre-installed environment with the most important libraries, as well as extremely a lot of examples. So if you want to start something and coding fast, this is a very good environment to start with. Well, every data science project starts with some importing and installing some libraries, as we can see here. So we install, for example, joblib, sklearn, another library to connect to S3. S3 is where we have some of our data. Then we continue with some more specific sklearn, as well as we add some of our own libraries. Where are our libraries? Yeah. Like this one, where all the magic essentially is happening. So even though you're going to see a lot of things today, most of the magic is happening on the back end, in functions that are not here so visible. Well, first thing first, we run this. We actually import the data that we want. You see that it's going to be quite fast because it's a really small data set. Finished already. Then we have the TF-IDF method, TF-IDF vectorizer. Here I just put some parameters which are indicative of what we're doing, and then we use this TF-IDF methodology in a pipeline, very useful, to keep only some of the components and not everything. Then we combine this table with the rest of the dataset, and eventually we are creating our train and test dataset, as we said earlier, right? Yep. Well, here you can see that, for example, our small dataset here has like 236K of transactions. It's about depth transactions, by the way, so negative transactions. And these are going to be used as training of the data. Now we go to the interesting stuff. We discussed about grid search before. So in the grid search, essentially we have to tweak a twist some of the criteria. Here we kept it a little bit small because we also would like to run it. We're not going to do the final run because it takes too much time, and so we have to just save it. But I would like to show you, for example, that one of the criteria we use is actually entropy. You could use Gini as well. Or the class weight could be balanced. We have other cases as well. Then you can play with a number of estimators. What's going to be like the minimum sample split between the nodes? How big is going to be like the minimum sample of the leaf, and what is the maximum number of features? After a lot of trainings and examples that we run and experiments, we actually came down to these ones that give us best results, but there is no absolute rule of what are the best parameters. That's why you have to run something like grid search in order to obtain them. Yep.
So basically it means that even if you have a model, then there's so much to tweak and tune, and that actually is what we're taking care of by this grid search algorithm. It's an optimization factor of your existing machine learning algorithm.
Exactly. Then what we do is that we actually put them in the dictionary, scoring, and you see here for the scoring, for example, that we are specifically interested in the AU criterion, the precision, the recall, and of course the accuracy. In our case, the recall and the precision is actually the most important. Yeah. Just to mention two things. It's nice to mention it now, right?
Yeah.
Thing that the recall actually shows like how many of the transactions that salary actually we managed to capture, and the precision says that from all the transactions that are not salary, how many of them we can actually capture. And excuse me, for depth, if it's not the depth, how many of that. So these are going to show how good how performant the model is. Yeah.
So and actually, it's been good to mention that I can easily create a model with 100% recall or 100% precision, but then my other feature, if I have 100% precision, my recall will probably be very low, because then I would just say that everything that I found is a depth, and then my precision would be good, but my recall will be terrible, because in most of the cases I'm wrong. And the other way around as well. If I have 100% recall, but only 20% precision, then my model is also not good. So it's critical to find the balance between those two indicators.
Indeed, especially in these cases where, for example, less than 10% of the transactions are actually salary, a model of 90% accuracy is something that you don't have to think of. Just put a random one. Yeah. Going down and almost here, we create the indices and everything else needed. Here you see, going down. Here you see actually how a grid search is actually looking like. Here we put the pipeline, the one that we actually saw before. It actually says all the steps that the algorithm is going to follow, from feature extraction to the model itself. Then we define the parameters. Then here this number of jobs actually says to SageMaker that it will use as many CPUs as possible. That's there's the parallelization. Then we have the k-fold, which is the split, the scoring, of course. Well, the refit is happening with our criterion. And when we run them, we're not going to do it now. We have the results ready. You see that it produces a result like that, which pretty much explains what are the criteria and the features used from the grid search for the model in order to produce the results.
It is good to jump to the feature set that we actually get out of this model, because else we're running out of time a little bit.
Running out of time, yeah. And, well, the result is here. We have all the results and combinations from the specific models, and you can see here that you actually have these lines. These show what is the our criterion, the accuracy, the precision, and the recall. And the one we saw, it is actually somewhere here. Yep, this model.
This is not actual results again. We'll show some of the real results later. But okay.
So going through these steps and these different models that actually grid search has created, we selected the one that best performs, has the best results. And here we have the results. Actually, this shows what is the importance of each variable. So not all the variables have the same significance, but on the other hand, we cannot measure them with a parameter like in logistic regression. So this gives us some feature importance, actually, up to an extent how many times this variable was used in the decision trees and what was the power of this variable in the decision trees. Yep. Here we have the number of the name of the variable, but as you can see, the 75th variable was actually the most significant one. Right, and the 77th. These are actual variables that are used from our model that we create in the feature extraction.
And I think it might be interesting to see that, so that we take 75 data points out of the transaction. So while we're only looking at basically 3 or 4 data fields to begin with, we look at the value of the transaction, we look at the description, at the date. That's pretty much it. We captured 75 features of that. For example, the order of words and the type of words that are in this description. And we don't know, of course, when we begin training this algorithm, which of them will lead to the best indication whether something is a debt or a salary. And that is what you see now in this algorithm. That is what this diagram shows. So as humans, we might think that something is a very important indicator to label something as a debt, while in fact it might be something else entirely, because it might be on number 10 or 20 of this list of 75.
Indeed. Well, that's pretty much it. Just the final one. Here we have all the curves, and we have actually the feature selection.
Oh. Yeah. Bas, when you bring your slides back, Bas, I'll ask Tassos 1 or 2 questions.
Please.
And if you have final questions for us, type them in right now, because we have a few minutes left.
We have only 2 minutes left? No, 5 minutes.
4 or 5 minutes max. Ivo Zethoff is asking, how do you balance the trade-off between model results? Is it just manual tweaking, or are more complex methods used?
As said, the grid search actually give me the solution, so I'm taking some specific parts, and this is essentially the final confusion matrix on which I'm taking my decision. In my case, I want to have a model that will have very good precision and very good recall, and I'm selecting the one that actually doesn't balance well between one another. Yeah.
And Evikan Ilyan is asking, you are using AWS SageMaker for this demo, but are there cases where cloud functions from, for instance, Google or AWS, Amazon Web Services, also used in production?
Not currently. Now we are using some parts that are from AWS and as well as from ING. But I think Bas done.
Yeah, we have this environment at ING Labs, and we like it to train the models on. But actually, that's another thing than of course running the actual software, which is usually done on ING's private infrastructure. And we also are using some of the. We also have a big data cluster at ING itself. So actually, data scientists can also use the internal tooling of ING. Yeah.
The model performance you were talking about.
Yeah. There it is. The model performance. This is what makes us proud. So as we said, we have transactions. We try to identify the depth and the salary, and the precision was 95% and the recall 84%. In this point, I want to say that This means that the model identified 84% of all the salaries that existed from all the transactions that we actually saw. And from the depths, which the model is almost done, I don't know how we can make it even better than that, even though we'll do. Well, 100%, almost 99.999 precision, and the recall of 93%. So 93% of the transactions that were actually depth were identified from the model, which is quite nice, very good.
It's subhuman level performance actually, because we actually talk to business people, of course, a lot as well.
That's important to say.
And actually, we always see that it's actually difficult to predict whether a transaction is a debt or is a salary. And our machine is actually doing better than trained humans already. So
and it's done automatically, so
it makes you proud, I can imagine.
Yeah, it is. Yeah, I think it's a nice use case.
Cool. Yeah. Time for a wrap up. Any use case?
We talked about machine learning models, and we thought this would be a nice example to put forward. But actually, if you are an ING customer, then we use a lot of this kind of machine learning models also in production. I brought one example of this, which is called Bekijk, vooruit. So it's a Dutch feature in the Dutch mobile app of ING, and you can use it to get a forecast of your prediction of your transactions in the next 35 days. So rather than just looking backwards, we're looking forward, kijk vooruit, to give you a prediction on several categories of your spending. For example, how much money you will be spending, we think, on your clothing, on your lunch, or on your expenses that you want to pursue. So this is maybe a nice touch to end up with.
Cool. A lot of questions still popping up. For instance, Daniel, who also would like to apply as a computer scientist from Utrecht University. And Anna is still busy. Alejo, what is the salary for a data scientist at ING, by the way? Can you predict that as well?
We did for free. We do it for free. We like it so much.
You mentioned it as a hobby, so
yeah, exactly.
No, but this was great, gentlemen.
Yeah,
and I also what I saw in the chat in the meantime. People really like this webinar, so thanks a lot for your contribution.
We thank you for inviting us to this brilliant place. I mean, it's really professional.
It was fun to do, and
brilliant experience. Yeah,
great. So we see you, and you as a participant. See you next time, Tassos.
Yeah, looking forward. We'll have better results and present again.
I think so too. We'll do something else entirely, or we'll present another use case, whatever. But actually, we're happy to present and to share some of this knowledge, and to indeed to start the conversation, because I think that's also important. We want to open up a bit and show what we do, and also, of course, to attract some talent to our company.
Yeah, great. Once again, this broadcast will be available on YouTube. Will be on Tweakers soon, and you can also replay this webinar. Thanks, Bas and Tassos, once again, and of course Anna for moderating the chat. Great insights from your daily practice. That was really valuable I think for all the participants. And of course, thank you for your questions and your comments. I hope to see you again next time. Enjoy your evening. Bye bye.
Thank you. Bye bye.
Bye. Good night.
Thanks.